Welcome everyone to the APH Virtual Excel Camp. This is day 2 of STEM Camp, Science, Technology, Electronics, and Mathematics. We are so glad to have you with us today. This camp is built for 11 to 13-year-olds, but everybody is welcome to join in, listen, and learn. Again, welcome to the APH Virtual Excel Camp, STEM Camp Day 2. We had some people share some photos with us. Maya was working on building a circuit. She has one picture where she's kind of leaning down with her hands on the circuit with the red spinner rolling away, and the next picture is her with her hands pulled away. You can see the snap circuit box off to the side behind her. And Miley's experiments, she is leaning down. She has the similar red top spinning. Looks like she has a couple batteries hooked in there in kind of a rectangular shaped design. And Jury was working on the extension activity, and I'm going to let one of the instructors describe this picture.
So this is Mary Kate, aka Dr. Short Circuit. So Jerry, instead of using the rigid snap wires in his extension activity, building the circuit, he used some of the jumper wires. He used the red and black jumper wires to connect his motor to his battery.
Well, very cool. I'm going to stop sharing and I'm going to turn it over to your instructors.
Hello, scientists. This is Mary Kate, aka Dr. Short Circuit. I'm glad you guys came back for day 2. So I wanted to start off, and I'm joined by, of course, Dr. Batteries Not Included. I wanted to start off by saying thank you for sending in your extension activities, and I want to know if there's anything interesting that you learned doing your extension activity. You can write in the chat. Actually, just write it in the chat for now. What was one interesting thing that you learned from doing your extension activity yesterday?
And while we're waiting for all of our friends to type in what they learned about their extension activity yesterday, I want to tell you something I learned. If I have too much electricity, it will burn my light bulbs out. So I was reviewing the household low-tech experiment that we were going to do today, just running through it one more time to make sure it was okay. And something went wrong because my light bulbs all burned out. So you will have to watch for a video as soon as I can get new light bulbs from Amazon, which they should be delivered tonight by 10. I love that Sharia has decided that this activity can be done in different ways. And I love that. I love the flexibility we have. As long as we create that complete circuit, the path doesn't have to be the same. I love it. Another comment we have, Dr. Short Circuit, is that the electronic pieces work differently. That is absolutely correct. Yep, what do you think about that, Dr. Short Circuit?
I like that. I think that each individual piece in our kit has a different purpose and works differently. Some might work similar, but they each have something different that they can do. Okay, so I want to review what is one thing that you learned yesterday about electricity. You can write in the chat. I want to know one thing that you learned yesterday about electricity.
Electricity is energy. That is absolutely right.
Okay.
And who can remember what are the pieces that we have in our energy? There were two specific terms that we started with. And while you're thinking of that, I'm going to put that in the chat. Energy can be dangerous and electricity can be dangerous. That is absolutely correct. Yes. We have to be careful, because if we're not following it correctly, if we remember, our electricity likes to follow a path. And we can be part of that path that our electricity follows, and then we would get zapped. So that's why we need to be so careful about that.
Good point, Dr. Batteries. We do not want to get zapped.
Exactly. And I'm loving that so many of our mad scientists are remembering that electrons and protons are part of the particles, the charged particles that create our energy. So I want you guys to throw in the chat, which one has a positive charge? If it's a proton, type a P. If it's a neutron, it's an electron, type an E. And you could even say neutron if you want. Yes, I hope that we all remembered what I said yesterday that helps me remember. Proton and positive both start with P. I love the power of alliteration.
Yes.
All right. So, Dr. Short Circuit, are we ready to review what it takes to be a good scientist today?
Yes, I think we are ready to review being a good scientist.
Awesome. I love that everybody had such a great experience with our project. So I want to review just a few things of being a good scientist. We follow directions. We ask questions. And then I've added a different step here, and we need to be organized. So I find that when I'm working on my snap circuit projects, I do a few things to help organize my space. One of the things that I notice is that if I get all of my pieces out of my box before I start to build, then that's easier for me. I can also organize my pieces and say, I need these certain pieces for step 1 for layer 1, and then I need these pieces for layer 2. And if I keep them in 2 separate spots by my breadboard, then that can help me to know where to reach to find the pieces that I need. If you guys got the pieces right from the box as you followed the step, put a B in the chat. But if you got them out all at once, put an A in the chat. I'd be super interested to know what your method is for organization. I see some people have experimented with B, getting them right out of the box. Some say A all the way. It seems like we're a little bit leaning towards reaching to the box and grabbing the piece that we need and then putting it on. So here's what I would like to challenge you guys to do today as you're working on our extension project. I would like to challenge you to try method A. Try reading all the instructions, finding all of the snap circuit pieces that you are going to need, organizing them by layer. So all of the step 1 pieces, layer 1 pieces are together, all of the layer 2 pieces are together, and then trying your build. Because it can really help us in everything we do in life if things are organized, if we know right where to get the stuff, and then we do a little preparation ahead of time. It's also very important to read all of the instructions before you start a project. I've had projects before where I decided to skip that step, and I had a tricky step thrown in on me that said, do this and this and this and this. And so I did that. And then the next step said, but before you do that, you got to make sure and do step C. And I went, oops, that did not work very well. So making sure that we read all of the instructions so we know and get that big picture idea of what our build is going to look like.
Dr. Battery's really
Leanne
fast.
popped in the, go
You
ahead.
are getting choppy every once in a while, especially when you get excited.
Oh no!
I'll just remind you to slow down and not so excited, which is a funny thing, but it's getting really choppy to hear you.
Oh, I'm so sorry about that. All right, I will try and rein in my mad scientist excitement.
This is Dr. Short Circuit, and I'm just going to remind you that when I'm building on camera, I take out all the pieces first, and I'll tell you what pieces I'm taking out before I start to build. So you can follow along as we go there.
Yep. So Dr. Short Circuit is following option A to help organize our containers as we build. I also saw a suggestion in the chat that we could take a few plastic containers or maybe some bowls. So maybe your project calls for you to use 4 of the 2-wire snaps. If you didn't want to have them scattered, you could put them all in a bowl, and you would know that in this bowl are my 2-wire snaps. And I know that when I'm all done with the pieces in this bowl, then I shouldn't need any 2-wire snaps. That's another great advantage of getting all of our pieces out before we do our project, because then we know exactly what pieces that we need, and we know we don't end up with some extra pieces at the end. If we do, we know we've skipped a step, right? All right. And then we are going to make sure that we do not eat or drink around our snap circuits, and that we are not touching the moving parts because we don't want to have any injuries. And the last step to be a good scientist that I'm going to talk about today is that we need to know our objective. So I would love to share with you guys the objective that we have for today. Our objectives are, I will describe the difference between open and closed circuits. And our next objective is that I will build series and parallel circuits. So we have 4 different types of circuits that we will be working on today. Some of those words are new. So I want you to put a Y in the chat if you have heard of an open circuit before. Oh, I'm seeing some answers coming in. We already have a great knowledge of what an open circuit is. I love that. Oh, and we have a little bit of hesitation. Well, an open circuit is a circuit where there's a break in our circuit. So as I'm imagining a circuit, if I have my hands up, but they're not touching, they're like open, right? There's no clear path for that electricity to flow and follow. Whereas in a closed circuit, it's like I take my hands in front of me and I'm holding them together. I can see a straight path from my hands to my arm, through my body, all the way to the other arm, back to my hands. That is a complete and closed circuit. Electricity will flow through that. Whereas if I break my hands apart, I have a gap, and the electricity cannot jump the gap. So that circuit is open. Then the other 2 vocab words that are very important that we're going to talk about is a series circuit
Dr.
and a
Dr.
parallel circuit.
Dr. Batteries, I was just thinking, let's hold off and do the last 2 vocabulary words, and after we do, and before we get to the circuits.
Oh, so now that we've talked about these open and closed circuits, we are going to build. Who is ready to build?
Yeah, I was just, Let's build 2 circuits.
Give me a me in the chat if you would like to build. And I think, Dr. Short Circuit, are we ready for cameras?
I think so.
Yes.
Let me get to my directions. Let's see. Let's see.
Dr. Short Circuit is going to be building the open and closed circuits on her desktop. So her desktop is called Mary Kate Desktop.
Okay, so we will be building project 2 today, which is the DC motor and switch. And that is on page 4, print page 4 or Braille page 7 of your manuals. And this one might look familiar because it's the one that you built yesterday in your extension activity. But we're going to use it again today. So the parts we'll need are the battery, which is B1, the switch, S1. This is the slide switch, the switch that you can turn on and off. Then we need the motor. We need 4 2 snaps. So we got our 2 snap wires, and we have 4 of them. And if they're stuck together, I'll pull them apart. Then we need 1 3 snap. And then we need the fan blade. I'm going to give you all a few seconds to get all of your things out. Okay. So our first layer of this project, and if you remember from doing this yesterday, our first layer, we put the battery from C6 to E6 with the positive end at C6. So we are going to have our battery and we're going to count. Remember this, the letters are our rows and the numbers are our columns. So we're going to count A, B, C, and 1, 2, 3, 4, 5, 6. And this is going to go vertically from top to bottom in column 6. Next, we are going to place the S1 switch from E3 to E5. And that is going to go horizontally because remember, if the letters stay the same, but the numbers change, it is in the same row. So we're going to go A, B, C, D, E, A, 1, 2, 3. We're going from 3 to 5. And make sure that your switch is in the off position when you plug it in. That way, when we connect everything, we can wait for it to do its magic until we turn it on. Next, we're going to place the motor from C3 to C5. So A, B, C, 1, 2, 3. And with the motor, it says that the positive end has to be at C5, at C5, so I have mine upside down. So the positive end needs to go to the right on this one. And you can feel, if you can read Braille, there's the positive sign, there's a plus sign in Braille in there. It is in UEB. Okay, so then we place the S1 switch. Oh, we already got that, sorry. Then we place a 3 snap from C2 to E2. So we have the 3 snap, and we're going to go A, B, C, 1, 2, and that's going to go vertically right there. Now, our second layer, we're going to be connecting all of our pieces using the 2 snaps. So we're going to place a 2 snap that connects the 3 snap to the motor. We're going to place a 2 snap connecting the motor to the battery. Then we're going to do one connecting the 3 snap to the switch. And then the switch to the battery. And I'm going to wait to see, I'm going to give you guys about 2 minutes to finish building this. Let me know in the chat when you are finished.
I can see Miley has a hand raised. Miley, do
Okay.
you have a question?
Well, I have a statement. Yesterday, whenever I was doing the assignment with my mom, I figured out whenever you have, you can't put like one of the snaps across the battery or else it won't work.
Oh, so Miley, am I understanding you right? Did you try to take a 3 snap and snap it on the 2 posts that are on the battery?
Yes.
Oh, and that makes the battery not work.
That is good to know. That's a very good observation you made.
I love that. Thank you so much for sharing. All right, Dr. Short Circuit, I can see 1, 2, 3, 4 of our scientists are finished.
Okay. So now we're going to put the fan blade on. We're going to get it so it stays in there. Let me see if I can.
Sometimes I find it tricky putting the fan blade on because the post from the motor has those 3 little posts that come out, and then there's notches in the bottom of the fan blade, and I just have to keep being persistent until I get everything lined up just right.
So if before we turn it on, we'll start at the battery and we will go counterclockwise. So we're going to go to left and we're going to look to make sure that we have everything connected and it is one path that goes around everything. So we're following from the battery and then to the left, the motor. And then, oh, there goes my fan blade. I'll put it back on in a minute. Then to the 2 snap wire, then down the 3 snap, then we're turning the corner and we're coming back to our switch and then back to our battery. We just did the whole rectangle and everything is connected. So now you can turn on your switch. Now, how many people, tell me in the chat if your fan came on, if your motor came on?
Personally, I'm feeling a lovely breeze coming from my fan. Feels delightful.
It is hot here today, so I can't wait. Okay. So, is this circuit, I'm turning off my motor just so it doesn't make a lot of noise. Is this circuit an open circuit or a closed circuit? When the switch is on and it's running, is it an open circuit or a closed circuit?
Oh, the chat is lighting up with the word closed. Yes.
Now, if I were to take off one of these two snaps, I'm taking off the snap that's connecting my switch to my battery. If I were to take that off and try to turn my motor on, what happens? What happens? Can someone?
Oh, Nadia says an open circuit.
An open circuit, and it doesn't work.
It doesn't work.
There is a break in this path here. There's nothing connecting this. It does not work. No matter how you try it, it won't work. The only way to get it to work again is to put the snap back, and now it works. So this is your open circuit and your closed circuit. And my question for you is, what happens? So we know that a closed circuit, an open circuit happens when there's a break in the wires or when there's a break in the path. So what causes your electricity to go out in your house? What can cause your electricity to go out in your house? What happens? You can write
A
it.
circuit break.
A circuit break. Yep.
Yeah, there's a break in the circuit. The power shuts down. We have a blackout. Yes, sometimes the weather can do it. Absolutely. And I love Baron's answer, a gap in the wires. So as Dr. Short Circuit and I were talking about this yesterday, we were talking about how we have had experiences where there's been a big storm and a tree has fallen down on some power lines. And so when the tree falls down on that power lines, it created an open circuit, right? There's a break in that path, and there's circuits all over in our home, in our city, in our town, in our state. And if there's a break anywhere in the circuit, it can have some pretty big impacts. Now, one circuit break, like if I have a circuit break here at my house in Utah, Dr. Short Circuit is not going to notice that.
No.
Because they have protections in place where we have smaller areas of circuits. Like the whole nation is not connected on the exact same circuit, because that would be really tricky. Like, I wonder if anybody would ever have power if we were all connected that way. What do you guys think? Probably not. Yeah. And then another way, so we know that if there's a break in the circuit, that we know that the power isn't going to come through and it's not going to power our devices. But there's something that can be done to help keep power in place, even if there happens to be like a circuit that might not be working. And I think that's where we get into series circuits and parallel circuits.
Yes.
So a series circuit is a closed circuit that follows one path. So if we think about that circuit that we just made to illustrate our open and closed circuit, do you guys think there's only one path or more than one path for that electricity to go? Kenji's thinking there's more than one. Nadia says there's one path for that to follow. I'm seeing a lot of answers of one path coming through the chat, and that is correct. There is just one path for our electricity to follow. It goes from the battery pack to the motor, down through the 3-wire snap circuit, over to the switch, and back to the battery. That is the circuit that it makes. But we can make another type of circuit, and it is called a parallel circuit. And a parallel circuit is a closed circuit, but it can follow two or more paths. So we want to get in and we want to illustrate this right now. And we want to show you how that works. So in order to be able to compare and contrast these circuits, I am going to build the series circuit on my board, which is on my workspace. And Mary Kate is going to build, or Dr. Short Circuit is going to build the parallel circuit on hers. So you guys would be welcome to choose which one of us you want to build with and follow along. But I think we are going to take the time and we are going to build those circuits.
I think you're going to build first and I'll build after you.
That sounds great.
Yeah. So you can choose, campers, you can choose which one you want to build, or you can just watch.
Awesome. All right, so my parts that I need to build my series circuit is, of course, I'm going to need that battery pack. I am going to need our motor, M1. I am going to need 4 2-snap wires. And I'm going to need the lamp, L1. I'm going to need the slide switch, S1. And I'm going to need the fan blade. I'm going to give you guys a minute to get those pieces out, and let me know in the chat when you're ready by typing in R. I'm going to say I have my pieces separated. I have the battery, the motor, 1 2-snap wire, and the lamp kind of in one area. Then I have the switch, 3 of the 2-snap wires, and the fan blade in another area. So I have separated them out for layer 1 and build layer 2. I'm seeing some R's in the chat. I think we might be getting close to being ready to build. All right. The first thing that we are going to do is I'm going to take the battery pack. And the battery pack is going to go on D4 to F4. So I'm starting at the upper left-hand corner. I'm counting down A, B, C, D. Then my finger is already on 1. I move over horizontally, 2, 3, 4. And I place my battery pack. My next step that I'm going to take is I'm going to put my lamp on. My lamp is placed from B2 to B4. And it looks like Maya has a question. Maya, you can go ahead and unmute. Oh, Maya says she is good. All right, so we are
Miles has his hand raised.
Oh, Miles has his hand raised. Thank you, Leanne.
Miles, I've given you permission to speak. We can't hear you, so if you could type your question in the chat, we'll work on getting to it.
All right. So the lamp goes from B2 to B4. So I'm going to count down the left-hand side, A, B, and then I count 1, 2. And I place my lamp. And my lamp doesn't have to be in a particular direction, so I don't worry about that one too much. Next thing I need to do is I need to get the motor on. And the motor does need to be in a particular direction. So the motor is placed on C2 to E2. And I want you to know that C2 is where the positive side needs to go. So I'm starting in the upper left-hand corner, counting down A, B, C. I come over one more to 2, and I make sure I place that positive part of my motor right there. And then the last thing for layer 1 is I need to put a 2 snap wire. And let me know how you guys are doing on that. Have you got those 3 pieces placed on your board?
And I have a question from a hand raised from Shreya. Shreya, I've turned on your mic. You want to ask your question?
Yes, ma'am. Oh, I can see Mrs. Batteries included screens, so I'm really confused how this goes.
You can't
Can
see
you-
her screen, so you want some more instruction on where to put the pieces?
Mm-hmm.
Okay. Thanks, Shreya. I will give you more description on where I put them. So Shreya, do you have any pieces on your board right now?
Yes, I do.
What pieces do you have on your board?
I have the batteries, lamp, the motor.
And the motor. Cool. So you're all caught up with this. All right. So I see 3 yeses in the chat that says maybe we're ready to go on. I have to confess that I get really excited sometimes. I think you can tell today. I must have had extra excitement with my breakfast. And so I get kind of talking frantically. So I need to slow down. All right. So we have our battery pack, our lamp, and our motor on our board. The next thing we need is a 2 snap wire. That 2 snap wire is going to be placed at F2 to F3. And I know since they both have F in them that they are going to be horizontal. So I'm starting at the upper left-hand corner and I'm counting down my letters. A, B, C, D, E, F. And then I'm going to go horizontally 1 over to F2 and place my snap wire on F2 and F3. Let me know when you have your 2 snap wire on. Nice. I see 2 that are ready. The 3rd, the 4th, we're flooding in. Fantastic. All right. So we have layer 1 all set on our board. Our layer 1 major players are there. The next thing that I want to do is I want to work on layer 2. And I'm going to start working on layer 2 by putting on my switch first. My switch S1, it's going to go from B4 to D4, or if it helps you to feel, it's going to connect my battery pack to my lamp. So I could feel the battery pack and feel like that top snap on the battery pack, and then feel up to and feel the lamp, and I could know I could place it that way. Or I could continue to count down like we have been counting down with the other pieces. And we're going to make sure our switch is slid to the off position. And let me know how you're doing on that one. Nice. We are feeling good about that. Great. I can actually see a big grin on Maya's face. So that is very encouraging. All right. Then the next thing we need to do is just finish up these gaps in our circuit with our 2 wires. So we have
batteries not included.
Yes.
You have a question from PJ. Does it matter which direction?
For this one, I don't think it does. That's an excellent question, but I don't think the switch matters. The motor matters because it needs to know, like, the electricity has to come in on the plus side and leave through the negative side for the motor to spin. But the switch, I don't think it matters which way it goes. Excellent question, PJ. So I have a 2-wire. This 2-wire needs to go on B2 to C2. Or I need to connect my lamp to my motor. So you can decide which way you want to do it. If you want to count down from on the posts and find B2 and connect it to C2, or if you want to find the lamp and find the motor and then put your snap wire in to connect. Let me know when you have it and you are ready. I love it. Here we go. I got that smile from Maya. That's what tells me we're ready to go, I think. My next 2-wire goes from E2 to F2. So again, you can choose. It's going to connect the motor, the negative side of the motor, to the 2 snap wire that we put down in layer 1. So it goes from E2 to F2. You can choose whether you count down or whether you find those 2 pieces and you connect them on. And I would like to know how you put it on. If you counted, type a C in the chat when you're done. And if you found the pieces, type an F. Nice. That is the great thing about having layer 1. When it's all done, it makes it easy to use the pieces themselves as like reference points. I love it. But PJ, we can always count on our grid. That always works. All right. I have 1 2 snap wire left that I just dropped in my lap. I need to connect the other side of that 2 snap wire in layer 1 to my battery pack. So what this is this connects F3 to F4. You can choose whether you're counting or choose whether you're using the layer 1 pieces as reference points to connect them. And then when you are finished with that, while we're waiting for everybody to finish, I just want you to take a moment and feel with your fingers. Shreya, what can I do to help you with your confusion? Would you like to, let's see. Can Shreya unmute?
Yes.
All right, Shreya, where did we get lost?
I got lost where the one more, you know, the one last 2, where that goes.
The last 2 wire?
Yes.
Okay, it goes on F3 to F4. And that should be connecting the bottom post of the battery pack to the 2 snap wire on layer 1.
I'm confused where it's not connecting for me.
So yours isn't connecting?
Yes.
So have you, so is there a gap between the battery post? Oh.
There's
So
the biggest gap. Sorry.
there's a really big gap. So this is an excellent point to bring up, Shreya. When we build our pieces like this, if we end up not connecting after the last piece, then we have to do some problem solving. And the way that I would problem solve this is I would go back to the first step and I would double check. Did I get my battery pack placed from D4 to F4? So I would go back and I would count that out and make sure my battery pack is from D4 to F4.
Which page is it on again?
Dr. Short Circuit, can you help with that?
Yes, it is on the instructions. Are you looking for the Braille instructions or the print instructions?
The one in the book I have.
The Braille instructions or the print instructions? It can be found, it's project 5, and it can be found on page 4 of the print book or page 7 of the Braille book.
Thank you.
All right. And then I'm a little worried if we take through and problem solve this whole one. Leanne, maybe you can help me out. Do we have time to go over and problem solve this, or should we move on to the other circuit now?
My suggestion is we'll move on to the other circuit, wipe it clean, and realize that you can go back and listen to this recording again.
Perfect. Thank you, Leanne. I wanted to make sure that we take a moment to feel all the way around our circuit and make sure that it is complete, that I don't have any gaps anywhere. And that was the problem that Shreya was coming up with. She felt around and went, uh-oh, I have a gap. And if you have a gap, then we've got a problem. The last step is we're going to put the fan blade on, and then we can turn our switch on. And I have one series circuit that runs my fan.
Okay, so Dr. Batteries, I have a question for you.
Yes.
What happens if you, now I see that both your light and your motor are working. What
Thank you.
What happens when you take the fan off and you turn it on? What
All right.
options can you make?
My fan blade is off. I'm turning on my switch and I can't see the light.
And can you hear the fan, the motor?
I can hear the motor running, but I do not see the light.
So there's one path that the electricity has to take, and is taking through the light and the motor. And the motor right now is spinning faster and it's taking up all the electricity. So the light isn't lighting. Because the electricity just has one path to follow. So now
Exactly.
I'll show you a different type of circuit which prevents that from happening, which prevents a part from hogging all the electricity. So we're going to build project 6, which is on Braille page, which is on Braille page 9, print page 14. Print page 9, Braille page 14 in your books. So we're going to start with the battery. You can just watch if you want to keep your series circuit already made, and then you can build both afterwards if you want. So we have our battery. our switch S1, which is the slide switch. We're going to need our lamp. We're going to need the motor, the fan blade. Most of these are the same parts that were used for Project 5. We're going to need 5 2 snaps. Find another 2 snap. We're going to need 1 3 snap and 1 4 snap. Trying to unhook this. Okay, so our directions say for the first layer, we are going to put the 4 snap from B2 to B6. So we're going to start up in the upper left-hand corner and go A, B, 1, 2. And that's going to go horizontally. Then we're going to place the motor with the positive end at C2, writing to E2. So we're going to C2 to E2. There. And then we're going to place the lamp from C3 to E3. And it's going to go right next to the motor. It's going to go parallel to the motor. Then we have our 3 snap is going to go from F2 to F4. A, B, C, D, E, F, 1, 2. And then our battery is going to go from D5 to F5. So A, B, C, D, 1, 2, 3, 4, 5.
All right, and Dr. Short Circuit, let's just take a moment real quick and make sure that our scientists are with us. Nadia has a question that says, where is the 3 snap? The 3 snap goes from F2 to F4.
Yes.
F2 to F4.
Yes, F2 to F4. Okay, let's start.
So let's check real quick. I believe that completes layer 1.
Yes,
is that correct?
That
so
is
let me
correct.
know in the chat if you have those pieces. I think that's 5 pieces placed in layer 1.
We should have the lamp, the motor, the battery, the 3 snap, and the 4 snap.
And Maya, looks like we have a hand raised. Did you have a question, Maya? Nadia says, where does the light go? The light goes from C3 to E3. So if you have already placed your motor, it should go directly parallel to the right of the motor. It's running from C3 to E3.
Okay, in the interest of time, I'm going to finish building layer 2 rather quickly, connecting everything, because we want to talk about the differences between these 2 circuits. So I am going to put the switch connecting the 4 snap to the battery. And again, making sure that it's in the off position. I am going to put a 2 snap connecting the 4 snap to the motor. And I'm going to put a 4 snap connecting the motor to, hold on, wait a second. Okay. I'm going to connect the force snap to the force snap to the lamp. And then I'm going to connect the motor to the 3 snap. And then the lamp to the 3 snap. And then finally, I'm connecting the 3 snap to the battery. So we have everything connected here, except the fan blade. Okay, so before we, because we don't have a lot of time, I'm going to turn my circuit on. Was anyone able to keep up with me there? Or should we just move on?
Oh, we have a couple that did.
Awesome. You are getting to be fast builders. But you can always build these if you weren't able to catch up, you can always build it later. So I'm going to turn on my motor. I'm going to turn on my switch, and I see a very bright light, and my motor is spinning. Dr. Batteries, turn on your switch, so let's compare. Which light is brighter? For those who can see, which light is brighter? The one in my parallel circuit or the one in the series circuit? Oops.
And it might be kind of tricky to see, but yes, so far I can see a couple say it is brighter in the parallel circuit.
If you look at our parallel circuit, there are 2 paths for the electricity. Because look, if we start at the battery, we come up through the switch, and we get here to B3, we can either go straight and then go through the motor, or we can turn left, or we can turn down and go to the lamp. So we can go 2 different paths. The electricity has 2 different paths it can choose, so it splits, and it can do both things at once. And watch, if I were to take my fan, just blew away. I'm not going to worry about that. There it is. If I were to have my everything going, and let's say, I just did what we're not supposed to do. I'm going to take off the fan blade because it's getting in the way. But if I have my fan and my light going, and let's say I disconnect my light, I took off one of the snaps connecting my light. What happened to my light? My light went off. But the motor, what happened to my motor? Did my motor go off?
No, says PJ,
Oh.
the motor did not go off.
The motor did not go off, but the light went off. So a parallel circuit has multiple paths. So the electricity, if the circuit breaks for one part of the circuit, there's a break in one part of the circuit, the other parts can keep going.
Exactly. And don't feel bad if you didn't keep up with us. We did do some pretty quick building. It's kind of tricky because we have a lot of stuff that we want to talk about, and we only have an hour with our fantastic scientists. I would take you for the whole day if I could. It would be wonderful. So Leanne will be emailing out to everybody the extension activities that we have for today. There's a scavenger hunt around your house, and then there's also some projects to build. We would love to see the pictures
scavenger
of
hunt
the
is
projects
tomorrow,
you
isn't
build.
it? The scavenger hunt's tomorrow.
I think there's one today too. Oh, it's a little Google hunt today.
Oh, Google Hunt. Okay, that's right. Okay.
Well, I want to thank all of our students for joining in, both those that are typing in the chat as well as those that are sharing their cameras. And thank you to my two instructors for wonderful instruction. I agree. I realize that we sometimes move a little quick, so we're going to work on slowing down tomorrow. So be ready. Feel free to watch the video link and see if you can follow those, because then you can pause instructors who speak really fast. And we will see you tomorrow. Have a great day building.